This is Module 1, Lesson 3, Properties of Real Numbers. After this lesson, you need to be able to recognize the properties of equality and identity, and evaluate numerical expressions by applying the commutative and associative properties. Let's learn the properties of equality. So our key concept here is our properties of equality. There are 3 of them that we're going to go through here and more that we will encounter later. So the first one is the reflexive property. This just states that any quantity is equal to itself, which seems kind of obvious. So for any number a, then a equals a. So 3 equals 3, or 9 plus 2 is equal to 9 plus 2. Pretty straightforward. This will come into play later, so you do need to understand what is happening. The second one is called the symmetric property. So if one quantity equals a second, then the second quantity equals the first. So if we had a and b, then if a equals b, then b equals a. Or with numbers, if 7 equals 3 plus 4, then 3 plus 4 equals 7. This one's important. When we want to switch things to the opposite of the equal sign, or maybe you don't like solving for a variable when things are on one side compared to the other, you can always switch the sides as long as everything stays the same. So if you notice, 7 and 3 plus 4 just changed sides, but what was on each side didn't change. They are still equal to what they were before and to each other. The third one is called the transitive property. This one says if one quantity equals a second and the second equals a third, then the first one equals the third. So kind of like a logic problem. In symbols with our letters, we have for any real numbers a, b, and c, if a equals b and b equals c, then a equals c. It might not make a lot of sense here, but if we look at our numerical example, if 5 plus 1 is equal to 2 plus 4, and 2 plus 4 was equal to 6, then 5 plus 1 must be equal to 6. Example 1. Identify properties of equality. Identify the property of equality used to justify each statement. Explain your reasoning. So part A, we have if 13 plus 25 equals 38, then 38 equals 13 plus 25. So based on what we see here, we have the same quantities from the first part to the second part. They just switched sides. This is the symmetric property, where we had 13 plus 25 equals 38, and then switched around 38 equals 13 plus 25. Part B, if y plus 4 equals y plus 4, then what property are we showing? That's the reflexive property. If we have one thing equal to itself, that's the reflexive property. Y plus 4 equals y plus 4. Same thing on both sides. On the side of your workbook, write down your thinking. So in part A, if 13 plus 25 equals 38, and 38 also equals 20 plus 18, what do you know about the expressions 13 plus 25 and 20 plus 18? What property did you use? Pause the video now and write down your thoughts. You should have noted that the two expressions must be equal since they are both equal to 38, and that is the transitive property. If one equals the second and the second equals the third, then the first and the third are equal. Check your understanding. Pause the video and identify the property of equality used for each statement. Check your answer. The first one is reflexive. The quantity is equal to itself. The second one is symmetric. Quantities that are equal are just switched. Example 2. Interpret properties of equality. Our real context here is cooking. If the amount of sugar in a recipe is equal to the amount of flour, plus 2 tablespoons, and the amount of flour plus 2 tablespoons is equal to the amount of milk, then the amount of sugar is equal to the amount of milk. Write a verbal expression in the spaces below. So here, it's not really numbers that we're using, we're just going to use words. So we know that sugar is equal to flour plus 2 tablespoons, and flour plus 2 tablespoons equals milk, then the sugar must be equal to the milk. If instead of using sugar, flour, and milk, if we say A is the amount of sugar, B is the amount of flour plus 2, and C is the amount of milk in the recipe, then if we plug in A, B, and C, we get the following algebraic expression. If A equals B and B equals C, then A equals C. So part B, the statement that we just had was an example of which property of equality? That was an example of our transitive property of equality. Check your understanding, read through the context sentence, and then answer part A and part B. Check your answer. In our original statement, it says the weight of a bag of oranges plus 13 is equal to 5 pounds. So, which quantity is equivalent to 5 pounds? 5 pounds is equal to the weight of oranges plus 13 ounces. The fact that we reversed the order makes it a statement of symmetric property. Originally, it was the weight plus 13 equals 5. We wrote it as 5 equals the weight plus 13. Switched. Example 3. Use properties of equality. Use the given property of equality to complete each statement. Part A, y minus 21 equals something, and they want us to use the reflexive property of equality. The reflexive property of equality states that any quantity equals itself, so y minus 21 must be equal to y minus 21. Part B, if 24 plus 11 equals 9 plus 26, and 9 plus 26 equals z, then 24 plus 11 equals what? Using the transitive property of equality. Well, with our transitive property, we would say that 24 plus 11 equals z. That's because it states that if one quantity, or 24 plus 11, equals a second quantity, 9 plus 26, and that second one equals a third quantity of z, then that first quantity must be equal to the last quantity. So we would say 24 plus 11 equals z. On the side, write down your thoughts. Avery says that in part B, z equals 35. Do you agree or disagree? Explain your reasoning. Pause the video now and write down your thoughts. You should have wrote something along the lines of, she is correct that z is 35, since both 24 plus 11 and 9 plus 6 and 9 plus 26 are equal to 35. Since we know that both of those are equal to z, then z must be equal to 35. Check your understanding. Use the given property of equality to complete each statement. Pause the video now and complete the check. Check your answers. First, we should have said that if 43 plus 9 equals 10 plus 42, and 10 plus 42 equals 52, then, based on the transitive property of equality, 43 plus 9 must also equal 52. Second, we're given 2m minus 1, wanting to use the reflexive property, which would make that equal to 2m minus 1, since a quantity is equal to itself for the reflexive property. Let's learn identities and inverses. The sum of any number a and 0 is equal to a. Thus, 0 is called the additive identity. If the sum of two numbers is equal to the additive identity, like 4 plus -4 equals 0, then those two numbers are called additive inverses. So we're going to look at these two words. First, the additive identity. All this means is that adding 0 to a number gives you the same number that you started with. So a plus 0 equals 0 plus a, switched, still equals a. 5 plus 0 equals 5, or 0 plus 5 equals 5. Adding 0 does not change the value. That's the additive identity. The additive inverse property is adding a number to its opposite will give you 0. So if you have a plus -a, you're going to get 0. Or 2 plus -2 will give you 0. Or they wrote it here as 7 minus 7, which is really the same as 7 plus -7, still get 0. Adding a number and its opposite will equal 0. That is the additive inverse property. Continuing to learn, here we're going to look at some multiplication properties. So the product of any number a and 1 is equal to a. Thus, 1 is called the multiplicative identity. The product of any number a and 0 is equal to 0. That is called the multiplicative property of 0. And then any two numbers with a product of 1 are called multiplicative inverses, or simply reciprocals. So let's go through each of these. First, we have the multiplicative identity. So any number times 1 is that same number. A times 1 is a, 1 times a is a. 4 times 1 is 4, 1 times 4 is 4. If you multiply by 1, using the multiplicative identity, you're going to get the same value you started with. The second property, the multiplicative property of 0, says any number times 0 is 0. So a times 0 is 0, 0 times a is 0, so 12 times 0 is 0, 0 times 12 is 0. Any number multiplying by 0 is going to get you 0, and it is rightfully named the multiplicative property of 0. Third, the multiplicative inverse property. So if you have a number, then multiplying by its reciprocal will give you 1. So every number a over b, as long as b is not 0, because you cannot divide by 0, there's one other number, b over a, its reciprocal. Multiplying those together will equal 1. It might be more difficult to understand in the symbols, so let's look down at our numerical examples. 2/3 times 3/2 equals 1. If we were to calculate it out real quick, for multiplying fractions, you just multiply straight across. So 2 times 3 is 6. On the bottom, 3 times 2 is 6. What's 6 divided by 6? 1. Skipping ahead, let's learn about the commutative and associative properties. An easy way to find the sum or product of numbers is to group or associate the numbers using the associative property. So first, let's start with the associative property. When you are dealing with adding or multiplying, the way that you group the numbers won't change your final sum or product. So for example, if you had a plus b first and then added c, that would be the same answer as if you added b plus c first and then added a. Or multiplying, if you multiplied a times b first, then multiplied by c, or if you did b times c first and then multiplied by a, you're still going to get the same answer. If we look at our numerical examples, here we have 2 plus 9, which is 11. 11 plus 4 is 15. So I knew one side was 15. If I check the other, 9 plus 4 first is 13. 13 plus 2 is also 15. A quantity is equal to itself. Reflexive property, yes. For multiplication, 3 times 6, 18. 18 times 5 is going to be 90. Or we could do the other way. 6 times 5 is 30. 30 times 3 equals 90. Sometimes this will be helpful because if you were trying to figure out the problem or the answer like I just did, 3 times 6 is 18. 18 times 5 is not a common multiplication fact that I know right off the top of my head. I had to think about it for a little bit. But if I had associated and used a different group first, 6 times 5 is 30. 30 times 3, I can multiply pretty quickly. Since 3 times 3 is just 9, add the 0, still get 90. So associating into different groups can help you find your answer a little simpler. Our other property is the commutative property. So this is like a rearranging kind of property. The order that you add or multiply doesn't change their sum or product. And the way they worded the examples here are sort of like the symmetric property. However, it's not always exactly the same. So if we look down at our numerical example, if we did 8 plus 12 first, we get 20. If we did 12 plus 8, we get 20. 4 times 9, 36. 9 times 4, 36. If you have more than two numbers, this is where the commutative, where you can put them in the order for multiplication or addition, that will come and help. So let's say I had 12 plus 15 plus 8, and I want to add those together. If I rearrange them, so instead of being this order, if I rearrange 12 plus 8 plus 15, I have the same numbers. They're in a different order, so the order that I add them doesn't matter. Now I can think back to the associative. I can add these two first and get 20, and then 20 plus 15 is 35. So rearranging things first can help us to put easier numbers together, which is the advantage of the commutative property. The same thing works for multiplication. Just be careful. The problem needs to involve only addition or only multiplication. If it involves subtraction or division, then you need to change your subtraction into adding a negative or change your division into multiplying by a fraction. Then you can use these properties. Example 7. Evaluate using the associative property. Our real context is personal finance. Jalen wants to add up how much money he spent on gasoline in July. He grabs the 4 receipts he has for July and writes the expression that represents the total amount he spent. Evaluate the expression to determine how much money Jalen spent on gasoline. We can see a picture of his 4 receipts. So first we're given $34.50. Our next one then would be $32.50, $23.25, finally $31.75. Next, we're going to group certain things together. Here, they are likely grouping the first two together, not just because they were first, but because they both end in 50 cents. If I add those two together, I'm going to end up with a whole dollar amount, which can help us to add a little quicker. If I look at the ones over here, $23.25 and $31.75, a 25-cent ending and a 75-cent ending would also make a whole dollar amount. So grouping those together could be helpful. Now I'm going to add the first two things together. $34.50 plus $32.50 is $67. They already added the other two together. Finally, combining our two groups, we can see $122. So we added groups that were easy together first, rather than just going add the first one, then add the next one, then add the next one, then add the last one. So write down your thinking. Why did we use the associative property to evaluate this expression? I briefly talked about it, but pause the video and write it in your own words. You should have put something along the lines about grouping numbers that are easier to add. Okay, I also mentioned about whole dollars. 50 cent plus 50 cent is a whole dollar. 25 cent plus 75 cent is a whole dollar. Check your understanding of using the associative property. So read through the situation. Again, this goes here and then it goes down from that. So for this, read through each step and determine what was done to help evaluate. Pause the video now and complete the check. Check your answer. So the first step they did, they grouped a specific thing together. That is the associative property. Next, if you could see, they rearranged those two numbers, which is our commutative property. Even though the commutative property wasn't in our example, it is here now. Finally, they just simplified and kept simplifying. Example 9, evaluate using the associative and commutative properties. Our real context is groceries. Jade buys groceries once each week, and she wants to calculate how much she spent on groceries over a 4-week period. Evaluate the expression to find out how much Jade has spent at the grocery store. We're given a table with the week and the amount that she spent. So we can see here we have 32, 27, 28, 33. Those are our numbers right here. Step 1, let's rearrange them so we put numbers that are going to be easier to add together. So they put 32 and 28 together, which leaves 27 and 33 to put together. Next, we're going to use the associative property to group things. So here they're grouping by the last number. 2 and 8 would make a 10, as would 7 and 3. Now, simplifying each set of parentheses, 32 plus 28 is 60. 27 plus 33 is also 60. Then simplifying by adding, we get 120. So Jade spent $120 over the 4 weeks. On the side, write down when did she use the commutative property, when did she use the associative property. Again, I did mention this, but please pause the video now and write it in your own words. You should have said step 1 is when she used the commutative property. She moved the 27 and the 28, so they were by numbers that were better to add. And step 2 is when she used the associative property. She grouped the ones that were easy to add together. Check your understanding using the commutative and associative properties to evaluate this complicated looking expression. Pause the video now and complete the check. Check your answer. You should have got this expression is equal to 36. If we use the commutative property first, I'm going to switch these two things. So 5/9 times 9/5. And then still multiplication times 9 times 4. I'm doing this because 9 times 4, those ones are easier to multiply, so I'm going to put them together. And fractions I'm going to put together. As it happens, putting these fractions together, they are reciprocals. 9 times 5 is 45, 9 times 5 is 45. Together they just multiply and equal 1. 1 times 9 times 4, so then 9 times 4 is just 36, times 1 is still 36.